Okay, in the next problem we have the function, another square root function, square root of x to the fourth minus 16x squared. And first we're asked to find the domain of f. Once again, this will be defined wherever x to the fourth minus 16x squared is greater than or equal to 0. So we can factor out an x squared, and we get x squared times the quantity x squared minus 4, which x squared minus 4 can still be factored. And so we end up with x squared times x plus 2 times x minus 2. Now, this is a place where we could use a sign chart apart from calculus or before calculus. You probably learned how to do something like this already. So we set up our number line, and we have zeros at 0, at negative 2, and at positive 2. And so we're going to pick a test value in each of those intervals, and we're going to evaluate the original function at those points, at those test values. And you should use the factored form. You'll see that it's much easier. So the first term is always going to be positive. X squared will always be positive. Let's try when x is negative 3. Negative 3 plus 2 is negative. Negative 3 minus 2 is negative. So we're going to have positive, negative, negative, which is positive. Plug in negative 1. First term is always positive. The second term will be positive, and then the third term negative. So positive, negative, positive is negative. Plug in x equals 1. We're going to get positive, positive, negative. So it stays negative. And you'll see later, or you should understand why we're getting at 0 we have a double root at 0, and that's going to cause it to stay negative. And then finally at 3 we plug in and we get positive, 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 which is positive. And so since this function is only defined when x to the fourth minus 16x squared is greater than or equal to 0, so our domain will be negative infinity to negative 2 inclusive, along with 2 inclusive to positive infinity. And so that will be the domain of this function. The way we test for part B, the way we test symmetry of the function is to plug in a negative x. And a function is even if you plug in negative x and you get the same thing back. So f of negative x equals f of x. Sometimes I say opposite inputs produce the same output. And if a function is even, it will be symmetric about the y-axis. A function is odd if f of negative x is equal to negative f of x, which means opposite inputs produce opposite outputs. And if a function is odd, it will be symmetric about the origin. So we should take our function and plug in negative x. And you should see when we plug in negative x, we're going to end up with the same exact function that we began with, square root of x to the fourth minus 16x squared. So opposite inputs produce the same output, and we have an even function. And the function is even and symmetric about the y-axis. In part C, we want to find the derivative of that, and that derivative will be by the chain rule. First of all, we have 1/2. Leave the inside alone, x to the fourth minus 16x squared quantity to the negative 1/2 power. Then we need to multiply that by the derivative of the inside function, which is 4x to the third minus 32x. And simplifying that just a bit, we would get 4x times the quantity x squared minus 8 over 2 times x to the square root of x to the fourth minus 16x squared. We can divide the 4 and the 2 and get just 2. And so the final form, we could still factor x squared minus 8, but I'm going to leave it for right now. 2x times the quantity x squared minus 8 divided by the square root of x to the fourth minus 16x squared. And finally, for part D, we want to find the slope of the line normal to the graph of f at x equals 5. So what we want to do is plug in x equals 5 into the derivative and then take the opposite reciprocal of that. And so f prime of 5 is going to give 2 times 5, which is 10. 5 squared is 25 minus 8, which is 17, divided by square root of x to the fourth.